So we're going to be doing 14.3 number 2, and yeah, we're going to go about this. Basically what this one looks like is it's from 10 here to 0 here, and then root 100 minus x squared, and from 0, and then y dx. So we got this guy here, and a couple of good ideas here is, first of all, what this guy means here. So is that x squared plus y squared equals 100, and thusly r equals 10. Awesome, perfect. And so now we're going to draw our little circle so we can convert. Oh, we're supposed to be converting this to polar coordinates. So cool. And so basically for this region here, this is for that x region. So you can clearly see that if it's from the x region, it goes from 0 to 10. That means it goes from here to here. So it's just in this region here, if you see that. And then you know that this is the half circle, and this is a half circle basically for this guy. So this is basically essentially a half circle. So this is what y equals here. So that's basically essentially a half circle. So the y region is here. So I don't know. So basically the y region kind of runs around this way, and the x region kind of runs around that way. And then you want to get the spot where they intersect, and they intersect right about here. You can see that they intersect right here. So you want to use that region, and pretty much that region only. So basically, if this guy goes from here to here to here to here to here to here, root 100 squared, that's your y, and then your x is 0 to x 10. Basically what you're going to want to do here is once you convert everything, you know that from your polar coordinates you have, I'm running out of room to write this stuff, but basically that y equals r sine theta, right? So you got that, and so we know that. So we know that's gonna be our r for here, and then we can kind of go about converting it more or less here. The other thing we have to think about is, so we can kind of convert our y's here. We also need to convert our x's, and so basically these are the way these are going to be. But then the way the other cookie's going to crumble is it's going to be from 0 to theta to pi over 2, and then from 0 to r to 10. Awesome. And the reason why that is basically because it goes from 0 because it basically the theta, the angle, is going to go, basically this is our angle 0 here, and then that's our angle pi over 2 there. So it basically goes kind of from 0 all the way up like so, and then it goes from, the radius goes from 0 to 10 because, well, the radius is 10, right? So you can kind of do that information what you will. So then we're going to rewrite this integral as such. We're going to rewrite it as pi over 2, 0, and then 10 to 0, right? And then we're going to write our dr and our d theta. Now it's very, very important to remember that it's r dr. R dr is super important. And then because we have a y here, we know that y, once you switch the polar coordinates, is r sine theta. So this is r sine theta. And essentially we can rewrite this a little bit just to make it nice and easy. So we can say pi over 2, 0, 10, 0, this one's r squared sine theta dr d theta. Now we can take this integral really nicely and really easily. Basically, you want to treat the sine theta. Some of you might be a little. You might want to say like, oh, this is. We jump straight to making this negative cosine theta or whatever. But remember, we're in dr, so we have to integrate with respect to r. So it's going to be r cubed over 3 sine theta looked at from 10 to 0 d theta, right? And then we're going to have our little guy here, pi over 2 and 0. Now this part, fairly straightforward here. Essentially what you're going to have is you're going to have, once we look at this and say, okay, you know, this is what this is here, so we're going to 2, 0, and then we're going to say, oh, okay, you know, 10 cubed is, well, 10 squared is 100, so 10 cubed is 1,000, so it's going to be 1,000 over 3 sine theta d theta. Now you can kind of do what you would like here. You can just kind of integrate with it. You can pull this guy out. Here, I'm not super bothered by this, so I'm just gonna take it and someone's phone right here. You just take this guy and it'll be fine. You just kind of feel like so.
It's my phone. My apologies.
Okay, you're all good. So you just take this guy, put this out here. Over 3. Pi over 2, 0, sine theta, and then this is 1,000 3. Because the integral of sine theta would be negative cosine theta, evaluated at 0, and there you go, right? So from here, again, should be reasonably simple. From here, you just kind of go and you say, oh, okay, you know, this is fine, you know. So you have, let's take it up here. In fact, right here. There you go. So we're gonna say, okay, so we've got our. We're gonna move this out. Yeah, and then we're gonna say, okay, this is no problem. So negative cosine of pi over 2 minus negative cosine of 0. And what that ends up being is 0 minus negative 1. That ends up being 1. And then 1, again, can't forget this guy, times 1,000 over 3. And the answer ends up being 1,000 right over 3. There you go. That's your that's the boy right there. It's the 1. Yeah. Yeah. It's a little hard to see, so let's see if we can get a little better color on there. That's a little better. You can kind of see the stuff a little better. Yeah, let me box this guy off here. And that's my nice little arrow coming all the way from down here. And so, yeah, that's how you do that. Fun times. Yeah, all right. Yeah.